All right, this was a lesson I was going to do last week, but decided to stick with monomials. So now we're going to do something which I think is actually simpler than what we did last week. By the way, I like how you guys worked together on the quiz afterwards. I think everybody got everything right when you worked as a group, which is good. Yeah, I'm going to have you take it after we go over the lesson. Do this lesson. So, like I normally like to do, I'm going to show you why this rule works, why we are able to divide each term by the bottom. If we just look at some numbers, not variables or anything, let's say we have 6 plus 8 minus 4 over 2. Now the easiest way to do this problem is to do 6 plus 8, which is 14, minus 4, which gives you 10, and then divide by 2, which gives you 5. But we know that when we're working with variables, for example, if it was x plus y minus z, you can't combine them. So the rule that we're going to be using is taking each term in the top and dividing by the single term on the bottom. And that's the gist of today's lesson. So it's another distributive type rule where you take each term on the top and divide by the bottom. If we do it that way, we get 6 over 2, which is 3, 8 over 2, which is 4, minus 4 over 2, which is 2. 7 minus 2 is 5, which is the same answer we got up here if we do it the short way. So you can take any number if you have 10, 20 terms on the top and just divide by the single term on bottom, and that will get you the correct answer. All right, so this leads us to the first example. Why can you not add 6x plus 3x squared? Because there is no exponent. I guess you could say it's an exponent of 1 for the 6x, but you can't add two different terms that have different exponents. So the first step we're going to do, I don't care how you write this step. You can literally just write distribute. I know it's kind of long, but it says that distribute the monomial in the denominator to each monomial in the numerator. And so all that really means, as wordy as that is just to take the first term and divide by the bottom term, then take the second and divide, and just keep going until you're through. And so it's going to look like this for this example. We're going to have 6x over 3x, okay, and it's going to be plus, so whatever this sign is, the next sign is going to carry over. So it's going to be plus 3x squared over 3x. Okay, so this term on the bottom should be the same. For this particular lesson, there's only going to be one term on the bottom. So it should look just like that. Now if it's two terms, you really can't do that, okay? It's not like you can take all the terms on the top and divide by the first term, and then take all the terms on the second and divide by the second. That mathematically doesn't work out. This is only true if you have a monomial, meaning a single term in the bottom. Okay? And then step 2, you're just going to divide them out. Divide each pair. So at this point, you should just have, however many terms you had on top, how many terms you should have now. So if you had 5 terms on top, we'd have 5 division problems. So we've simplified these before. What is 6x over 3x? Would not be 2x. Just 2, right. The x's are going to cancel, and then just divide 6 over 3, which is 2. How about 3x squared over 3x? I'm going to put a 1 there. Maybe that'll help you. It's just x, right? The 3's cancel, and x squared over x to the first, subtract the exponents, is just x. Okay, and that's it. It's very simple. Just a matter of distributing. Okay. So we're just going to work this out on one page because I think you guys get the concept. I'm going to take the 6x cubed and divide by 2x to the 5th. Minus 2x squared. So again, the minus just carries over. And then minus 4 over 2x to the 5th. So again, every term on the bottom should be the same. It should all be 2x to the fifth. All right, so what is 6x cubed over 2x to the fifth? First of all, 6 over 2 is 3, but it's close. The 5 is on the bottom, it's bigger. So the x squared, make sure you put it on the bottom, not the top, because 5 is bigger than 3. Okay, and then we have 2 over 2, which is going to cancel and become 1. And x squared over x to the fifth is going to give you x cubed on the bottom. Remember, the 5 is bigger, so the answer goes on the bottom of the fraction. And the last one you can't do anything. Actually, yeah, you can. I'm sorry. 4 over 2. And so the 4 is on top, so the 2 goes on top, but the x to the fifth remains. And that's going to be your answer. Where for this particular example, every variable ends up being in the denominator, and that's because this power was bigger than all the powers in the numerator. If that happens, then all your variables are going to end up in the denominator like we had there. Say what? I don't know why you would.
Some of these, you just don't bring down an x, and then on the other ones, you bring down an x.
Okay, explain. Tell me where.
Like on example 1, you bring down the x, but on example 2, then you bring down x.
Yeah, because 2 is bigger than 1, so the x goes on top.
Yep, that's what I was explaining, exactly. The answer goes wherever the bigger exponent is. All right, number 3. See if I can bring this one down so we can read it. There we go. All right, this has 2 variables, and this will be our last example, and I'll get you the worksheet. We're going to take the 3xy squared, divide by 3xy. And then again, this sign's going to carry over, plus 9x to the fifth y over 3xy minus 15x to the fifth y to the sixth over 3xy. Every time I do this, just to make sure the term on the bottom are the same. Also check to make sure I got my signs right. And anything else you can do to make sure that you didn't make any mistakes copying the problem down. Okay, so we got 3xy squared over y. The 3's are going to cancel, the x's are going to cancel, and like we've been talking about, y squared over y to the first, the bigger power is on top. This is going to be y for that one. Okay, 9 over 3 is 3. X to the fifth, putting that missing exponent of 1 over x to the first is x to the fourth, and then the y's cancel. And then 15 over 3 is 5. This is an x to the first. It'd be hard for me to write this. This is a y to the first. So x to the fifth over x to the first is x to the fourth. Y to the sixth over y to the first is y to the fifth. And with this particular example, there are no fractions left because all the powers were bigger on the top, which is different from the last one. The power on the bottom was bigger than all the other powers. And that's it. Pretty simple stuff. Any other questions? What if it was, let's just throw one out here real quick since we have a little bit of time. Say we had 3x to the fifth plus y to the fourth, and you don't have to copy this down, minus z to the 7 all over 0x y z cubed. Wouldn't be 0. Wouldn't be 1. So what is this going to become on the bottom? Nope, won't become 1. It becomes 0. 0 times anything is 0. If you have something that's not 0 and you divide by 0, that ends up being undefined. Right, you can't divide by 0. 0 doesn't go into another number. 0 doesn't go into 9, it doesn't go into 7. No matter how many times you multiply 0, you're always at 0. So that's an undefined one.